Next we have number 10, where we have to find which of the following operations on Q, the set of rational numbers given below, have identities, that means identity elements. The first one is this: A star B is A minus B. Suppose star has an identity E in Q. Then A star E and E star A will be equal to A for all rational numbers A. That means A minus E and E minus A will be equal to A for all rational numbers A. In particular, 0 is also equal to E minus 0, because this equation is true for all rational numbers A, so you can take A equal to 0. But this equation gives you what? E equal to 0. And now you use this value back in this equation. What do you get? A is equal to 0 minus A, that is minus A. But this should be true for all rational numbers A, which obviously is impossible. And that is why our supposition is wrong. That means there is no identity. Part 2, A star B is equal to A squared plus B squared. Solution: again, suppose that star has an identity E in Q. Then, just like part 1, A star E and E star A will be equal to A for all rational numbers A. But this time, A star E is A squared plus E squared and E star A is E squared plus A squared. But then, A minus A squared is E squared, which you get from this equation, and E squared is always non-negative, because E is after all a real number. And this should happen for all A belonging to Q. That means for every rational number A minus A squared has to be non-negative, which however is not true. For example, 2 is a rational number for which this quantity is negative, and that is why things have gone wrong. So our supposition here also is wrong. So for this operation also there is no identity. Next, part 3, where A star B is A plus AB. Solution: because we are again supposing the exact same thing, so I haven't written that. You know what it is. So suppose there is an identity E in Q. So in this case also, A star E and E star A are both equal to A for all rational numbers A. Now A star E is A plus AE and E star A is E plus EA. And you can already guess that here also something will go wrong. Now we are free to choose any rational number in place of A. Say we choose A equal to 1. Then what do we get from this equation? 1 plus E equals 1. That means E is equal to 0. That's what we get. But then, from the fact that A is also equal to E plus EA, you get the fact that A has to then be 0 for all rational numbers A, which obviously is impossible. So here also our supposition is wrong. That means there is no identity element. In part 4, A star B is the square of A minus B. Solution: this time we are even more brief. So suppose there is an identity E in Q. Then this condition is true. This is A star E and this is E star A. In this case, both are equal, and that is equal to A for all A belonging to Q. This symbol stands for the phrase "for all." Okay, it's a symbol from mathematical logic. It looks kind of upside down capital A. You can use it if you want. So that implies what? In particular, you can take A equal to 0, obtaining this 0 minus E whole squared equal to 0, from which of course it easily follows that E is equal to 0. And what does that imply? Now if you use this value of E back in this condition, you get A square equal to A for all A belonging to Q, which however is not true. For example, 2 squared is not equal to 2, although 2 is a rational number. So we have got a contradiction. Sometimes you can write like this to indicate that we have got a contradiction. Two implication symbols. Implication means this one and the other one coming from the other side. They are clashing. However, I recommend that you do not use it when you write on your exam paper. because, well, this is India, that's why. Even if you write something right, if that thing is not available in the book, marks will be deducted. But anyway, so what does this say? It says that our supposition again here also is wrong. And that is why in this case also there is no identity element. In part 5, A star B is AB divided by 4. Solution, in this case it's completely different. You note this fact, for any rational number A star 4 and 4 star A, which in this case are both equal, are equal to A. And that is why 4 is really an identity for the operation star. You need to, of course, also make sure that the identity is inside the set. 4 is really a rational number. And finally, we have number 6, where A star B is AB square. I won't do it for you. I am leaving it to you. The hint is that this one also does not have identity. Next, number 11. Let A be the Cartesian product of two copies of the set of natural numbers. And let star be the binary operation on A given by the following equation. Note that the elements in A are ordered pairs of natural numbers. So you take two such ordered pairs and their star value is this ordered pair. The sum of their first coordinates, comma, the sum of their second coordinates. We have to show that this operation star is both commutative and associative. And we have to also find an identity element for star if any exists. To show commutativity, we take two elements A, B and C, D in A and calculate their star value. In a particular order, say we take this one first followed by this one. Then by the definition of star, this is A plus C, B plus D. Now addition of natural numbers itself is commutative. We already know this fact. So in place of A plus C, we can write C plus A. And in place of B plus D, we can write D plus B. This thing, however, is C, D star A, B. So that is just commutativity, and that is why star is commutative. And you can similarly prove that star is also associative using the fact that addition of natural numbers itself is associative. That part I am leaving to you. Don't forget that to show associativity, you are going to need three such pairs of natural numbers. And next we show that this operation star actually has no identity. And to prove that, we forcefully suppose that it has an identity, say alpha, beta in A. Then for any A, B in A, alpha, beta star A, B should be equal to A, B, which means this alpha plus A, beta plus B is equal to A, B. And this in turn means alpha plus A is equal to A and beta plus B is equal to B. So after cancelling these A's and B's, you get alpha and beta both equal to 0, which however is a problem because your alpha, beta is supposed to be a pair, an ordered pair of natural numbers, and 0 is not a natural number. So that is why your supposition is wrong, and this proves that there is no identity. Next, number 12, where we have to state whether each of the following two statements is true or false, and we need to justify also. The first one says that for any arbitrary operation star on n, binary operation of course, A star A is equal to A for all natural numbers A. And the second statement is this: if star is a commutative operation on n, commutative binary operation, then for any natural numbers A, B and C, A star B star C is equal to C star B star A. Statement 1 is obviously false. For example, if star is ordinary addition, then of course it's a binary operation on n. Then 1 star 1 is not equal to 1 because it's 2. Statement 2 is true. If our operation star is commutative, then for any natural numbers A, B and C, let's consider this left hand side, A star B star C. Because star is commutative, we can change the order. You can write B star C first, followed by A. But then again inside the brackets you can still change order and write B star C as C star B. So that is your right hand side, and that is why this statement is true. And finally number 13, the final exercise. Define star on n by A star B equal to A cube plus B cube. We have to choose the correct option. I did not feel like writing commutative associative, so I just wrote C and A. Star is both commutative and associative, that is option A. Star is commutative but not associative, that is B. Star is associative but not commutative, that is C. And star is neither commutative nor associative, that is option D. Solution: star is commutative and you have to prove it. It's just a one-line proof. But star is not associative because of this fact. You calculate 1 star 1, star 2 and 1 star 2, you will get different values. That is why the option is B.